Alright, so in this problem, I have 2 to the power of 20 minus 9. So the first thing I'm going to do is rewrite 20 here as 10 times 2. So now I have 2 to the power of 10 times 2 minus 9. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2, that's going to equal 2 to the power of 10 to the power of 2. Now I have this minus 9, which I'm going to rewrite as 3 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power of 10 and b is 3. So now I have 2 to the power of 10 plus 3 times 2 to the power of 10 minus 3. Now, if you guys already didn't know, 2 to the power of 10, that's simply equal to 1024. So now I have 1024 plus 3 times 1024 minus 3. And 1024 plus 3, that's going to be 1027. So I have 1027 times 1024 minus 3, that's 1021. Now, 1027 I can rewrite as 1000 plus 27. And 1021 I can rewrite as 1000 plus 21. So now I have 1000 plus 27 times 1000 plus 21. So to solve this, I'm actually going to distribute. So I'm going to start by distributing the 1000 here. So I have 1000 times 1000, which is 1000 squared, plus 1000 times 21, plus now I'm going to distribute the 27. So now I have 27 times 1000 plus, at the end, 27 times 21. So now first off, 1000 squared, that's simply equal to 1 million. 21 times 1000, that's 21,000. 27 times 1000 is 27,000. And finally, 27 times 21, that's going to be 567. So now all there's left to do is add all of these up. So I'm going to start from the ends to the beginning. So 567 plus 27,000. That's going to be 27,567. And now this plus 21,000, that's going to be 48,567. And now this plus 1 million, that's 1,048,567. So that is my answer. Alright, so in this problem, I have 8 to the power of x is equal to 16. So to solve this, I'm going to first start by rewriting both of these. So 8, this is the same thing as 2 to the power of 3. And 16, this is the same thing as, because this is double of 8, 2 to the power of 4. So now if I replace 2 to the power of 3 with 8 and 2 to the power of 4 with 16, I get 2 to the power of 3 to the power of x is equal to 2 to the power of 4. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x, that's going to equal 2 to the power of 3 times x, which is 2 to the power of 3x, and this is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, this is the same thing as m is equal to n. So, meaning these two exponents are equal to each other, meaning 3x is equal to 4. Now, to solve this, I'm going to go ahead and divide both sides by 3. These two cancel out, and now I have x is equal to 4 over 3. And this is the same thing as 1 and 1/3. Now I actually have a second method to solving this problem. So for my second method, Again, first start with a to the power of x is equal to 16. Now, I'm going to, instead of just simply putting 8 and 16 in different forms, I'm actually going to take the log on both sides. So now I have log 8 to the power of x is equal to log 16. Now, if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log a to the power of x, and I can move x to the front. So this is going to equal x times log 8, which is equal to log 16. Now I'm going to divide both sides by log 8. So then these two cancel out, and I have x is equal to log 16 over log 8. Now log 16, this is the same thing as log 8 times 2. And if I have something in the form log a times b, this is equal to log a plus log b. So in this case, log a times 2, that's going to equal log a plus log 2 over log 8, which is the same thing as log 8 over log 8 plus log 2 over log 8. And log 8 and log 8, these two cancel out, so now I have x is equal to 1 plus log 2, which is log 2 over log 8. This is the same thing as log 2 to the power of 3. And now remember, I can move my exponent to the front, so now I have 1 plus log 2 over 3 times log 2. Now these two log 2's can simply cancel out. So now I have x is equal to 1 plus 1 over 3, which is equal to 1 1/3. So this is my answer. Alright, so in this problem, I have x is equal to x over 9. So, to solve this, I'm going to first start by subtracting x over 9 on both sides. So now these two cancel out, and now I have x minus x over 9 is equal to 0. Now I'm going to go ahead and multiply both sides by 9. So now I have x minus x over 9 times 9 is equal to 0 times 9. Well, everyone knows that 0 times any number is simply equal to itself. So 0 times 9, that's simply equal to 0. And now the reason I multiplied 9 on both sides is to get rid of this denominator, this 9 as a denominator. So now when I multiply 9 with x minus x over 9, the 9 distributes. 9 times x is 9x, and 9 times negative x over 9, these two 9's simply cancel out, so I'll simply just be left with negative x. Now I have 9x minus x is equal to 0. 9x minus x is 8x, so I have 8x is equal to 0. And this is simple. All I have to do is divide both sides by 8. These two cancel out. And now I have x is equal to 0 divided by 8, which is 0. Now I also have a second method to solving this problem. And this is actually an easier method. So my initial problem was x is equal to x over 9. And this time, instead of subtracting x over 9 on both sides, I can simply just start by multiplying 9 on both sides. So then these two automatically cancel out, and 9 times x is 9x. So I have 9x is equal to x. Now I'm going to go ahead and subtract x on both sides. And I have 9x minus x, which is 8x, is equal to 0. Now if I divide both sides by 8, I have x is equal to 0 divided by 8, which is 0. So that is a second method of solving this problem.